This video is brought to you by Skillshare. Hi and welcome to another very exciting tutorial. Today we're going to discover the power of asynchronous and concurrent programming in Swift and also have a look at how to use web APIs and JSON data in 2021 with Swift 5.5. We'll have a look at async and await, which transforms asynchronous functions such as those using completion handlers to become more readable and more correct. Therefore, we're going to build a sample app called SwiftyPixum that downloads a number of images using the lorem-pixum API that delivers some Unsplash images. So to get started, I have created a little starter project that is really nothing fancy. We have a VStack that includes a little heading with a large title font. We have a subheading or subheadline with some text. And the most interesting part is actually the list that we're going to populate later on with the images that we're going to asynchronously download from the web using the async image that is also new with Swift 5.5 and Swift UI. We're going to asynchronously download the picture list with a click on our Load Pictures button. So this is where we're going to add some code later on. So to have a look at where we're getting the images from, this is going to be pixum.photos. So this is a lorem-pixum service, so kind of like lorem-ipsum, but lorem-pixum for images, so that we can use some easy and stylish placeholder photos. And as you can see, this API has several nice endpoints. For example, we can just specify the size with a width and height of an image, or just a squared image by just supplying either height or width. And we're actually most interested in the list images function here. And as you can see, the endpoint that we have to use is v2, so version 2 list. And then there is also some query parameters that we can use to limit the number of items that we get using limit. And we're going to set this to something around 10, for example. And you will also notice that this is what we will actually receive. So this is one data package within an array. And just to have a look at what we can expect, I'm going to just have a quick call to this API. So I'm going to just copy this URL here into my PAW application. You could use something like rested or just use your browser to actually have a look at the results, but this is a little bit nicer because we can see everything in a very structured way. As you can see, these are all the items that we get. And if we now maybe add this parameter, this query parameter, with the limit, and we set this to 10, and then just refresh our call here, then you can see that we get 10 items in an array. With the ID, we get the author, width, height. So as you can see, these are rather large images. And we get the download URL that we're going to use to actually get the image into our application. And now to do so, if we go back into our app, we're going to create a new file. So I'm going to press on Content View, pressing Command N on my keyboard, and we're going to create a new Swift file, and I'm going to call that Pixel Service. And if we have a look at the response that we get from our call that we made, and then we can create a quick data model to work with in our demo application. So there is really no change in what you would have done in earlier versions of Swift here. So we're just going to create a struct that is going to be called, maybe let's say, a random picture or random image. It's going to be codable and identifiable. Codable so that we can work with a JSON decoder, and identifiable so that we can put it into a for each view, for example. So what we're going to need is an ID that we get as a string. As you can see here, this is going to be our ID here, and we're going to need the author, and we're going to need the download URL. So just 3 data points that we're going to add here. So the author, also a string, and the download underscore URL, also a string. And since we receive a list of images, I'm going to just create another struct, going to call it picture list. It's also going to be codable, and here we'll have our list, which is an array of random pictures. So this is actually our data model that we have to work with. This video's sponsor is Skillshare. Skillshare is an online learning community with thousands of inspiring classes for creative and curious people like you. You can explore new skills, deepen existing passions, and get lost in creativity. They offer classes designed for real life and all the circumstances that come with it. They are short and to the point and can easily fit into a tight schedule. I'm following one class at the moment that I find extremely helpful when it comes to app design. It covers the benefits of using and create effective design systems to make design work easier, faster, and better. The first 1,000 of my subscribers to click the link in the description will get a 1-month free trial of Skillshare so you can start exploring your creativity today. Thank you, Skillshare, for sponsoring this video. With this data model ready, we can maybe create our pixel service class. Let me just call it pixel service right here. And this is going to be an observable object so that we can use this pixel service or a pixel service object later on in Swift UI to actually populate our user interface with the data that we download from the web. And therefore, we are going to create a published private settable variable for the picture list, which we're going to initialize with a picture list, and we can maybe just create a list here with one random picture with an ID, let's say 0, and we could maybe even get some data from here. So we have an author here. So let's pass that along, and also a download URL, which is going to be cool so that we can even see something even if we use this demo initialization. We could also leave that blank and put a placeholder image in any way in our user interface. So actually, it's just important that we initialize our published picture list right here. And we're also going to add another published private. We're also going to add another published property into our class right here, which will indicate if we're currently fetching data, so that we can display something like a progress view during the fetching process. And with that done, all that our pixel service actually needs is a way to fetch our images. And we're going to do this using the new Swift concurrency feature. So if you have a look at this graphic, and you can see that we're working with 2 actors, or that we will try to act with 2 actors. And actors enable you to structure your app into actors on background threads and actors on the main thread. And a main actor that we have here in the upper level is a globally unique actor who performs his tasks on the main thread. And we use now concurrent binding, so that as you can see, as long as we are on the main actor, we're doing something like UI stuff. And then at some point, we're going to fetch our picture list. So when fetch picture list calls load, it suspends itself, releasing the main thread to run UI jobs, and when load finishes, the fetch picture list again runs on the main thread, and where it's allowed to set the published values, and we're going to populate our user interface. So this is how we're trying to achieve that using concurrent binding. So how do we do that in code? So first of all, we're going to create a new function called fetch picture list. And to specify that this function is asynchronous, you have to tell the compiler that this function is actually asynchronous with the keyword async. And since the load function that we're going to create is going to pass an error thrown by a data from function, we also have to specify that this function throws. So this is going to be our fetch picture list function, and this is going to be a main actor. So for that part, we're ready. So what we can do is we can set, as soon as we call that, we can set is fetching to true. And now, since we want the actual loading action to happen in a separate actor, what we have to do is create such an actor, and we're going to do that right above our class definition. Maybe in line 10, we're creating a private actor, and we're going to call that picture service store. And within this service store, we're going to create a loaded picture list, which is going to be a picture list. We can just simply initialize that right here, picture list. Let's maybe just copy the initialization from here that we're going to use. And what we'll also need is, of course, our URL that we will call. And maybe let's just use private var URL components to create this URL. So I'm going to use a URL components object here. Let's use a computed property here for the components, which are URL components. And now let's supply them with the correct URL components, of course. So if we have a look at this object, then you can see that we can specify things like a scheme, host, user, and so on. And if we have a look at a URL, then I'd like to show you what components we actually have, having a look at the Pick Some Photos service that we're going to use. So HTTPS is, of course, the scheme that we're going to use. We have a host name, which is picsome.photos. We have a path, or our endpoint, that we're going to use, which is version 2 and list. And then we have the query part, which limits our request to 10 items that we want to receive. And using our components object, what we're going to do is we're going to use the scheme, set that to HTTPS. We're going to set the host, which is going to be picsome.photos. We're going to use a path, which is going to be version 2 / version 2 / list. And we're going to have the query component, which is going to be limit equals 10. And then we have to return these components. And with that, we can create a URL also in a computed property right here. So let's just use the URL components and access the URL and force unwrap this, since we know that this is going to work. So this was just the prequel. Now let's come to the main part, where we'll actually download the information from the API, and we're going to create a load function. And as you remember, this is going to be on a separate actor, and this is why we actually define this actor right here. But it is going to be an asynchronous function. So again, here we'll define that as asynchronous, and also this function throws as well, because we're going to use the load data function, or the data from function from the URL session that does throw an error, and so we have to pass it along through all the functions that we actually use here. So this function throws, and of course our fetch picture list function throws as well. And what we're going to return is a picture list. And to get that, we have to use a URL session shared, and then use the data from URL. So we'll just use data from URL, and that's it. And what this function does is that it can throw an error and it will return a data object and an URL response. So we will get both of them. So let data, and we can also get a response. And since this can throw an error, we have to try this, and we will also await. So using await in this way, this runs sequentially in a job in the task, and while it's waiting for the server response, this job suspends itself, releasing the task's thread. So what we also need to do is, since we're using try, we have to put that in a do block right here, and then catch the error and say, for example, print. And then we'll print the error and its localized description. And with that in place, we can actually now work with the data that we get here. And therefore, I'm going to use a guard let statement. So we're going to use the HTTP response to see if everything is okay. So if the response that we get, we can cast that to an HTTP URL response, and also check if the HTTP response and the status code is equal to 200, so okay. Then if this works, it's fine, we can continue. But otherwise, if we get an error, we'll print the response, and we'll also throw an error, and therefore we still need actually to define an enumeration of possible errors. So let's just do that right above our picture service store actor. I'm going to create an enumeration here, call it download error of type error. And then we will have two cases, one which is not okay, and a second case, which is a JSON decoder error. All right, so let's go back. So in this case, since we just checked if the status code is equal to 200, so this would be okay. We're here. What we're going to do here is throwing the download error not okay. And then since we check that and we now know that we have an HTTP response and everything went well, we can now actually access the data. So we're going to use another guard let statement, looking for the decoded or for the data that we get. And here again, we can use a try statement using the JSON decoder object called decode, and then we will receive a list of random pictures. So we're going to have an array of random pictures using the data type here, and we're going to decode that from our data object. And if this does not work, then we will throw another error, which is going to be the download error JSON decoder error. And as you can see, we still get this this compiler error here saying this is only available in iOS 15, of course. So I'm currently working with the beta of Xcode 13. So this is going to be available when iOS 15 is released. All of that we're doing here. What I have to do still here in my Xcode version is to change the deployment target or the deployment info to iOS 15 in my project settings, so that we can actually work with that. But as soon as I did that, should be fine actually. So we of course have to return something here, but for now we're fine. We have the decoded data. We handled the error, so everything's fine here as well. But when we have our decoded data and we can work with that, what we can do is go ahead with our loaded picture list that we created and initialize it with a list that we have now, which is our decoded data. And then we can, of course, also return our loaded picture list. And of course, also after we caught the error, we'll also return our loaded picture list. Might be empty right here if nothing of all of that did work. So let's build that real quickly again. And all the errors disappeared. Now, this is the function in a separate actor that we want to call from our main actor. So let's scroll down again and have a look at our fetch picture list function that actually is a main actor. And to work with our load function here, we're going to create a private property here, call that store, initialize it with our picture service store. And then in our fetch picture list function, what we can do is using our published picture list and then try and await our store to load. And with that, we've almost created this scenario. We will just have to deal with the isFetching property that we're also working with here. And what we do here is actually we use the defer statement to set this isFetching to false. Right above, we try to await our store to load. And the defer statement is used for executing code just before transferring program control outside of the scope that the statement appears in. So even when we're throwing an error to exit the fetch picture list function, we still need to set isFetching in this defer statement before any possible early exit. And with that, our pixel service file and all the pixel service code is actually ready to be used in our content view. So let's have a look at that and create a state object for the picture service, or the pixel service, initialize it with the pixel service. So now we have a connection with the published objects that we have here in our observable object pixel service class, and between the state object here in our content view, and we can use that very easily. So instead of using for each to actually just iterate through some numbers, we're now going to iterate through our picture service. So let's just remove everything within these parentheses here. So we're using our picture service or pixel service using the picture list and the list in this object. And then we can actually access the picture in this array. And for the author, we're just going to remove everything from here using string interpolation to access the picture and its author. And instead of a rectangle, we're just going to maybe keep the frame, the clipped, and the corner radius. But what we're going to do instead is we use an async image, which loads images from the web asynchronously, given a URL. And of course, we have a URL, which is coming from a string in our picture, and its download URL that we received from our API. So in this case, what we can also do is do some modifications with our image. For example, make it resizable. Also, maybe change the aspect ratio, content mode, fill. And also a cool thing of this async image is that we can specify a placeholder. Maybe just correcting this typo here. And in this placeholder, I'm just going to add a color, maybe blue. And then we can just reuse the code that we used earlier to create our frame size, clip the image, and also give it a nice corner radius. So this is how we display the images actually. But now how do we get them, or how do we fetch the images? So what we have to do is we create an asynchronous task with also a new keyword, which is going to be task. And within this task, we try and await our pixel service, which also, as you can see, the auto-completion tells us that this is going to run asynchronously. We want to actually fetch our picture list. So you create an asynchronous task with the task and its curly braces, and because it's asynchronous, you have to await its completion, and because it throws, we have to try to catch any errors. So with that done, we can have one last adjustment right here for our label of the button. What we can do, for example, is change the overlay. And if our pixel service is actually fetching, what we're going to do is replace or add a progress view right here, so that we can indicate that something is happening in the background. So this is going to be a uppercase P, of course. And there seem to be some missing curly braces, and let's add one here, one right there. Just format the code again, build our app real quickly, and then I'm going to run this in the simulator, and let's see if this works and if we can download our images and scroll through them. Should work real nicely. So here we are, and as you can see, we are already preloading our first image that we have used to initialize our demo content. So if I now press the load images function, we get all of the other images and we can scroll through them. They're downloaded asynchronously really quickly. And if you have a look at the size of these images and the amount of memory that we're filling with them and how fast they were downloaded and not blocking actually the main thread, this is really cool to work in that way. So now you know how to work with the new concurrency features in Swift. So we've got an introduction into that. You've also seen how to work with APIs in 2021 with the new features that are now available. So thank you very much for watching, and I'll see you in the next one. Bye.